Have you ever thought about how following a simple recipe is actually a lot like chemistry? Well, today, we're going to connect something you do all the time, making a meal, to the trillions of chemical reactions that are firing away inside your body right this second. It's a wild journey, from the kitchen counter all the way down to your cells. Let's get into it.
I know it sounds a little out there, but seriously, what does a grilled cheese sandwich have to do with you being alive? By the end of this, you're going to see that the logic you use to make lunch is pretty much the exact same logic your cells are using to keep you going. It all boils down to having the perfect recipe.
So, let's start somewhere we all know and love, the kitchen. We're about to make some grilled cheese sandwiches, but yeah, we've got a little bit of a supply problem we have to figure out first.
Okay, here's our recipe. And if you look at it, it's basically a chemical equation, right? Our ingredients, or our reactants, are 2 slices of bread and 1 slice of cheese. And the product? 1 delicious grilled cheese sandwich. Easy enough.
All right, let's see what we've got. In the bread box, we're working with 16 slices of bread. So that's our first ingredient.
And in the fridge, whoa, we've got 40 slices of cheese. So right off the bat, you can see the issue. Our ingredients are totally out of whack with our recipe.
And that brings us to the most important question. If you just start making sandwiches, which ingredient is going to be the one that stops the whole operation? Is it going to be the bread, or is it going to be the cheese?
So let's just do the math real quick. With our 16 slices of bread, we'd only need 8 slices of cheese. And we've got tons of cheese, so that's fine. But if you flip it to use all 40 of those cheese slices, you would need a staggering 80 slices of bread. We don't have anywhere close to that. So the bread is our bottleneck. It's going to run out first and shut everything down.
And just like that, you've stumbled upon a huge concept in chemistry, the limiting reagent. It's really just a fancy way of saying it's the ingredient you run out of first. The bread limits how many sandwiches we can make. It's basically the boss of this whole reaction.
So, what's the final score? Well, with 16 slices of bread, we can make exactly 8 sandwiches. We use up every last slice of bread, and we're left with a whopping 32 slices of cheese. See? The bread, our limiting reagent, called all the shots.
Okay, so that was the kitchen. Now let's take that exact same logic and scale it way, way up. We're moving from the kitchen to the chemistry lab, where the recipes aren't for sandwiches, they're for, well, pretty much everything else in the universe. The ingredients just get a little more interesting.
And that's because chemists have their own kind of recipe book. They've developed a super precise language to describe exactly how things combine and react with each other.
I mean, look at this. This is the recipe for making pure iron from iron ore. It looks way more complicated than our sandwich, I get it. But the principle is identical. Those big numbers out front, that's the ratio. It's telling you that you need exactly 2 molecules of iron ore and 3 atoms of carbon to get 4 atoms of pure iron. That ratio is everything.
But chemists have an extra little wrinkle they have to deal with that we didn't have in the kitchen. It's not just about counting the atoms, they also have to balance the electrical charge. And this is where things get really, really precise.
To do this, chemists have this really clever trick called the half-reaction method. Just think of it like trying to balance a seesaw. They look at the electrical charge of all the ingredients on one side and the charge of all the products on the other. If they don't match up perfectly, the recipe is just plain wrong. So they add or subtract these tiny negative things called electrons until both sides are perfectly level. And here's why that is so important. Look at this reaction. Before they balance it, the charge on the left side is +2, but on the right, it's +3. In chemistry, that's impossible. It literally breaks the laws of physics. It's like starting with 2 slices of bread and somehow ending up with 3. But after the chemists work their magic and balance those electrons, look at that. Both sides have a perfect net charge of +6. Now, the recipe can actually happen.
All right, now for the final and honestly the most amazing leap of all. We're going to take all these ideas, recipes, limiting ingredients, balancing charges, and we're going inside your own cells. Because it turns out the most sophisticated, most incredible chemistry lab on the planet is you. You see, when your body gets energy from the food you eat, it doesn't just do one big explosive combustion reaction. That would be incredibly wasteful and frankly pretty dangerous. Instead, it uses a whole series of tiny, super-controlled reactions to pull out energy one little piece at a time. It's a brilliant process called stepwise oxidation.
So take a simple molecule like methane. Instead of just burning it all at once to get carbon dioxide, your body's systems take it apart step by step by step.
Each one of these steps releases just a tiny bit of energy, which your cells can safely capture and put to use. It's all about getting the most bang for your buck, with perfect control.
So who's running these thousands of incredibly precise, multi-step recipes inside of you? Because it's definitely not happening by accident. Your cells have what you could call master chefs, these specialized molecules that run every single step of every single reaction.
So let me introduce you to the toolkit. You've got these molecules, NAD+ and FAD, that act like tiny, rechargeable batteries, just zipping energy around the cell where it's needed. And then you've got the chefs themselves, enzymes, called dehydrogenases. These are the molecular masters that control every single part of the recipe with unbelievable precision. Now this is where it gets really elegant. Your body can use the exact same ingredient for completely different jobs. Take heme, for example. It's the molecule that makes your blood red. In one protein kitchen, called hemoglobin, its job is to carry oxygen. But in a different kitchen, cytochrome C, it carries electrons. And in a third kitchen, cytochrome P450, its job is to activate oxygen to get other reactions started. Same ingredient, but the kitchen it's in completely changes its function.
And the power of these cellular chefs is just mind-blowing. Cytochrome P450 can pull off reactions at normal body temperature that would otherwise need crazy high industrial heat. It is so powerful that it's been called the biological equivalent of a blowtorch. And by the way, this is the family of enzymes in your liver that breaks down most of the medicines you take. A true molecular powerhouse.
So there you have it. We went from a simple grilled cheese sandwich, limited by how much bread we had, all the way to a cellular blowtorch running some of the most complex reactions imaginable inside you. And through that whole journey, that one core principle holds true. It's all about having the right ingredients in the right amounts, following a perfectly balanced recipe.
So from digesting your last meal to you even processing this very sentence, your body is managing an uncountable number of intricate recipes to absolute perfection. It really makes you wonder, doesn't it? What other incredible, complex chemistry is going on inside you right now that we're only just beginning to understand? Thanks for joining me.